So, welcome you all in the 7th lecture of Electronics Measurement and Instrumentation. I, Dr. Indu Prabha Singh from Shri Ram Swaroop Memorial College of Engineering and Management, here to discuss in the 7th lecture about the digital frequency meter and the calibration of the instrument. So, first I will discuss the digital multimeter. What is digital multimeter and what are the different application of digital multimeter? Then we will I will discuss what is the requirement of the calibration of instrument and how the calibration is done in house and from the standard that is available at the national laboratories of the countries. So, this is the digital multimeter. We can see this is the digital multimeter which is showing the frequency in the digital form. So, suppose we want to measure the frequency of any instrument. So, what is frequency? Frequency means the cycle that is in 1 second completed by any instrument. So, any circuit or any oscillator, suppose we have designed an oscillator and we want to measure, we design that oscillator by calculation of different components values, and after designing that oscillator, we want to measure whether the designed oscillator is producing the same frequency what we have expected or it is producing different frequency. So, that oscillator we can measure by this instrument, that is digital frequency meter. So, digital frequency meter we can measure the any type of signal frequency that is repeated in nature, periodic signal. So, we can measure if it is producing the square waveform, rectangular waveform, triangular waveform or sinusoidal waveform. So, we can measure frequency of any periodic signal, any type of signal. So, how we can measure? Because we know the frequency means the number of cycles passed in 1 second. So, if we fix an AND gate, if we we use an AND gate, we know that AND gate, if we make a truth table of AND gate, then we know the AND gate is producing high output when both the inputs are 1. If any one input is 0, the output of AND gate is 0. So, we can simply use AND gate, and if we pass a pulse of 1 second through one end of this AND gate, and at second end, second terminal, we will pass the frequency, we will pass the signal whose frequency we want to measure. So, this op amp will produce 1 when this instrument is 1, when this terminal is at 1 and when both the terminals are at 1. So, in 1 second, whatever frequency, whatever the cycles are passed through this AND gate, that will represent the frequency of the signal. So, what is the basic block diagram of this signal? That there is an amplifier, there is a schematic trigger circuit, there is a start stop gate and electronics counter. So, if any unknown frequency signal we have to apply, we have to amplify if the signal amplitude is very low. Generally in AC, generally in electronic circuit, the signal amplitude is low. So, we need an amplifier circuit. But if we are using any electrical signal whose amplitude is very high, then we can reduce the amplitude by using attenuators. So, unknown frequency is applied to the amplifier circuit, and amplifier circuit amplifies that signal, and suppose the signal is in sinusoidal waveform as shown here. So, that sinusoidal waveform appears across the amplifier and it is in the amplified form. Then it is passed through the schematic trigger circuit. So, the schematic trigger circuit is a circuit which convert any type of waveform into square waveform. So, this schematic trigger circuit produces the square waveform, and that square waveform is used, this edge of this upgoing edge of the input signal is applied to the start gate. So, start stop gate starts counting the the frequency of the signal when this leading edge of the signal is appears. So, when this trailing edge of the signal is appears, then this will stop the counting. So, start stop gate is starting and this will count the signal, and when it stops, that will electronics counter is there, and then electronic counter will count it, and there is 7 segment display device that will display the output like this way. So, this is the block diagram of digital frequency meter. So, we can see in this block diagram that there is a crystal oscillator of 1 megahertz generally we use. So, crystal oscillator is used because this oscillator will produce a very stable frequency, and its frequency is not changing with the time, or with it is not affected by the any parameter, other parameters. So, we need a crystal oscillator. So, crystal oscillator is producing 1 megahertz frequency. It is in sinusoidal in nature because it is an oscillator. Then we have to convert this sinusoidal waveform into square waveform. So, again we are using a schematic circuit. So, inside that frequency digital frequency meter, there is a crystal oscillator, then a schematic circuit. Then we need there is different time based selector switch, there are different time based generator circuits we need, because if the frequency of any measure any unknown quantity is very high. So, we need to measure it for the low time period. So, this 1 megahertz frequency, if we know that f is equal to 1 by t, okay. So, we know that f is equal to 1 by t. So, here the frequency is 1 megahertz. So, it is 1 by t is 1 microsecond. So, this is 1 microsecond. Then we have this 1, 2, 3, 4, 5, 6 decade counters are there. So, as we know, in a decade counter we are using 4 flip flops, and we are designing the decade counter in such a way that when this is passed through a decade counter, then the frequency is divided by 10. We know if we use 1 flip flop, and if we pass through the signal in a counter, and after the first flip flop the signal is divided by 2. So, similarly there are divided by 10, we are using decade counters. So, signal is divided by 10. So, first the 1 megahertz signal, so 1 microsecond, then again divided by 10 means frequency is divided by 10. So, the time is multiplied by 10 because f is equal to 1 by t. So, there are 10 microsecond. Similarly, if we divide 10 microsecond, the frequency we divide by 10, then this time period is improved by 10 times. So, there are so many range of the time period of there. Then this circuit is connected to schematic trigger again, so that this is again converted into this square waveform, and there is a gate. So, what will happen, suppose we have the time based selector switch at this position. So, this is showing the 100 microsecond. It means this switch, when the leading edge of this waveform appears, then this gate is on. This gate will send 1 to the this AND gate, high input to the AND gate. And when this trailing edge of this signal appears, suppose a square waveform is there. So, when the trailing edge of this signal appears, then this will switch off this AND gate. Okay, gate will switch off, and so there is no signal at the AND gate. Now, the input signal is amplified by the amplifier. Generally, we use stages of amplifier. The first amplifier is the buffer amplifier, so that it will not affect the it will not load the previous circuit, and then there are stage of amplifiers that will amplify the input signal. Then again this input signal is again converted into square waveform through the schematic circuit. So, as it is put at the 100 microsecond. So, this signal is at this AND gate, there is signal which there is a square waveform which has a band which has a time period of 100 microsecond, and here is a signal which has unknown frequency. So, if this signal, suppose in 100 microsecond, the signal that is passed through this schematic this AND gate, suppose the 100 pulses are passed through this AND gate. So, 100 pulses are passed in 100 microsecond. So, we have to calculate how many pulses will pass through 1 second. So, that is the frequency of the frequency of the unknown input. So, now after that we have a decimal counter that will count from 0 to 9, and then we have a 7 segment display device that will display the signal. So, this is the total function of this digital frequency meter. Suppose we have put this knob, the time base selector at 1 second. So, whatever the number of pulses pass through this AND gate, that is calculated by the digital counter and displayed at the digital unit display unit. So, that in 1 second how many cycles are passed, that is the frequency of the signal. So, this is the function of the frequency meter. Now, after frequency meter I will discuss the calibration of the instrument. So, what is the need of calibration? Suppose we are using any multimeter or voltmeter and we are measuring the voltage or the current by that instrument. So, we have to assure that this instrument accuracy is very high. Accuracy means ki how close the reading of the instrument with the true value. So, we need that the instrument measure very accurate of any unknown quantity. So, for this we need a calibration. So, in calibration we compare our instrument with the standard one. So, by comparison we can see that whether our instrument is accurate or what is the tolerance of our instrument, is there any error. So, we can take when we suppose if our instrument is having any error. So, after when we take the reading of that unknown quantity, then we have to add yes, there is an error of this. So, we have to add or subtract the error to find out the accurate value. So, calibration of any instrument is one prime process used to maintain instrument accuracy. The process of calibration involves configuring instrument, provide sample measurement result within an acceptable result. So, this basically we need a reference circuit, a reference measurement, that means we need standard equipment to measure the to calibrate our instrument. So, as a thumb of rule, the accuracy of the standard instrument, which instrument we are using as a reference for the calibration of our instrument. So, that instrument has an accuracy of more than 10 times of the instrument which we want to measure. And sometimes suppose we want to measure in our college laboratory. So, yes, 3:1 is also acceptable sometimes. So, generally what an industry, suppose in an industry we are using any industry, there is suppose 100 voltmeters are there. So, these 100 voltmeters are required to be calibrated, but we can't send all the 100 voltmeter to the national laboratories, because our instrument should be comparable with the instrument that is placed at the national standard laboratory of the any country. So, what we will do in 200 instrument, we will select 5 instrument, 5 voltmeters or 10 voltmeter, and periodically we will send it to the country's national standard laboratory. So, because in every measurement or calibration, the national laboratory will charge some values, and if we will send all the 100 meters to the national laboratory, then the charges are more. And the second thing is that there is loss of production when the instrument is went for the calibration purpose. So, we will and this instrument because we have to calibrate our instrument with the country's national standards, that is the reference. So, we will send 10 instrument there, and when this 10 instrument is calibrated with the national country's national standard compared with then the national instrument country's national instrument will send a report of this key, what is the accuracy of your instrument and whether your instrument is useful or not. So, that they will send us the report. So, according to that we know that yes, these are the instrument which has this accuracy. So, then that instrument acts as a working instrument, working standard for our laboratory, and by this we can compare other instruments. So, if such instrument, if we do not want to measure our instrument, we do not want to calibrate to our instrument through the national laboratory, or we have no facility to send there, then that can be, we have any standard instrument in our laboratory and we can compare it our instrument by this. So, there are two important parameters that in every calibration we have to define, that is, one is the instrument tolerance, ki how much error our instrument is giving and what is the operating range of the instrument. So, calibration tolerance is maximum allowable deviation between a standard of the known accuracy and the test equipment. So, what is the need of calibration? So, restoring the accuracy of instrument, adjusting or repairing the instrument which is out of calibration. We have to minimize the uncertainty of error, ensuring the reliability and consistency of the instrument and keeping our measurement within specification of limits. So, and by calibrating our instrument we have to building our trust, confidence and reliability. And generally in calibration, through calibration we basically establish a traceability with the national or international standards, because ultimately we are comparing our instrument with the instrument that is put at the national standard laboratory. So, generally in our college or for the laboratory purpose, we can use some instrument, that is digital we have a digital multimeter, we can use it as a standard and we can calibrate the different analog voltmeters or analog multimeter by comparing the result with that digital multimeter. So, that digital multimeter also act as a standard instrument for the calibration purpose of the instrument that we are using in our college or our laboratory. So, types of calibration. So, yes, there is in-house calibration that I have discussed. We can use our digital multimeter or the instrument that is more accurate to measure the lower accurate instrument, or we can use third party calibration, means either we can use a national laboratory as a standard or we can use some third party that is providing the calibration certificate, that they are having a standard instrument with them and they will calibrate, they will compare our instrument with that and they will give us a certificate ki what accuracy is there. So, and that laboratories are accredited by the government. So, in college or in our lab, we can measure, suppose we have calibrated one instrument by any third party or the national instrument, suppose we are having that standard voltmeter with us. So, in voltmeter we know that voltage is measured across any resistance or any circuit. So, we will place our voltmeter which we want to calibrate in parallel to that voltmeter, and both the voltmeters are kept parallel to the DC supply voltage. So, we will see we will vary the voltage of DC power supply and we will note down the reading of both the voltmeters, and if the reading of this voltmeter that we have to calibrate is equal to the standard DC voltmeter, or it is if it is equal to this reading, then it means ki our instrument is very accurate, and if there is any deviation then we have to note down ki what deviation is there, that is the error. So, this is the way of using a voltmeter which we want to calibrate. Similarly, if we want to calibrate our ammeter, so what we will do, we will again put it in series, because our instrument the ammeter is always connected in series in which we want to measure the current. So, there is one current limiting resistance, suppose if current value is more, then that will be limited by the current limiting resistor. Then we will put a standard DC ammeter here and there we will put a ammeter that we want to calibrate. Then we will compare both the reading of both the instrument. In comparison, suppose we have a meter that has a reading that has a range of 1 to 10 volt, then we can divide it into 10 steps, that we compare, we will send the supply of 1 ampere and we will compare the reading of both these meters, then 2, then 3, then 4. So, similarly, we can measure the compare these two instruments. So, whatever the if instrument value is same, so means our instrument is very accurate, and if there is any deviation, then we have to read down the reading, and then by compiling that readings, we will find out what is the tolerance of our instrument and what is the accuracy, what is the errors in our instrument. So, whenever we calibrate, we measure any unknown quantity, then we will keep in mind ki yes, this is the tolerance of our instrument. So, the reading may vary this much percentage. Similarly, calibration of AC voltmeter and ammeter, the same way we will use a AC supply here, and in AC supply we will calibrate both the instrument, compare both the instrument, and similarly we will note down the readings of the instrument. So, AC supply, again the voltmeter is connected in parallel, in ammeter is connected in series. So, by this method we can calculate the we can calibrate our instrument through the standard instrument, and that standard instrument we may calibrate with the third party or with the national standard laboratory, because this instrument should be very accurate, otherwise the calibration has no purpose, because we have to calibrate this instrument so that it is traceable to the national laboratory instrument. So, that standard we should follow. So, this instrument should be very accurate and it should be traceable to the national laboratory. Then suppose we want to calibrate wattmeter. So, again wattmeter has a current coil and a voltage coil. So, voltage coil, current coil is put at the series with this, and voltage coil is put with the parallel to this. So, we can see here the current, this ammeter, standard ammeter is here, and then this ammeter coil, current coil is placed in series with this. Here we see the voltmeter is there, standard voltmeter is there. So, we have to put the voltage coil in parallel to this. Okay. So, this will be calibrated through the standard voltmeter and standard ammeter. Similarly, we can use digital multimeter as an standard instrument for the measurement of our different analog devices, analog instruments. So, suppose we are having analog voltmeter. So, we can put this multimeter in parallel to the DC supply, and similarly the second instrument whose we want to calibrate will put in parallel to that. And suppose we want to measure the current, then we will put both the instrument in series. So, digital instrument is more accurate than the analog instrument. So, in laboratory purpose we can use the digital instrument as an standard instrument, and we can measure our instrument analog instrument with comparing with the digital instrument. It is better if we calibrate our digital instrument with the third party or the national instrument, and we will get the certificate of that. So, that it will show ki yes, our instrument is standard and calibration is done properly. Similarly, if we are using digital voltmeter, a digital multimeter or digital anything. So, if we have a higher handheld, we know that the bench type digital voltmeter is more accurate than the handheld digital voltmeter, and handheld digital meter. So, if we have a high performance handheld digital voltmeter, then we can calibrate the low accuracy digital voltmeter with that meter. Similarly, if we have a digital voltmeter which is bench type. So, bench type instrument is considered as more accurate than the handheld instrument. So, we can use that bench type instrument to calibrate our handheld instrument. So, this type of calibration is also done. So, basically calibration is done for the purpose of calibration is to verify that our instrument is working properly and it is very accurate. Accurate means ki it is showing the true value very close to the true value. So, this is the measurement of this instrument. So, these are the few of the calibration instrument. One is the voltage calibrator. So, this is directly used for the calibration purpose, and this is the current calibrator. So, directly these are the standard instrument which we can use the calibration purpose. So, here we can directly calibrate the voltage because we do not need a standard instrument, these are the standard instruments. So, if any instrument we want to measure, so these are the instrument which is not generally used. So, we have to put the knob here and we have to see whether there is what is the accuracy of instrument, there is any tolerance or not. So, that we can measure by this voltage calibrator. Similarly, there is an handheld calibrator by which we can use the current instrument, we can use the instrument whether if we want to measure the distal ammeter or the distal voltmeter. So, we can generally use this instrument. So, thank you from my side.